All right. First of all, can you guys hear me? All right, who can hear me? Hands up. Who came here because it was the best meetup tonight? Hands up. Very good. Who came because they knew about the free beer? Hands up. Fair enough, at least someone's honest. Who came in here because they read the abstracts? Oh, I know. All right. All right. Well, ladies and gentlemen, my name is Marek. I go by the name of Mr. Shu online. It's a long story. I'm happy to talk about that later. In here, I'm happen to represent Slido. And if you read the abstract, which was the minority, thank you very much, you would have seen there that I happen to be head of data at Slido. And that's an animal we don't normally sort of find in nature. So let's first of all sort of describe what people ask this, like, what do you normally do as head of data? It's a very good question. I was like contemplating how do I explain this to people who basically like will have very different frames of references. Well, hopefully there's this guy. So look, if we take at these sort of pictures in here, going from top left down to bottom right, we have what we would call the sort of head of engineering type, you know, nice hoodie, ready to build stuff, and so on and so forth. Then we have the head of sales, you know, happy to sort of sell you stuff straight away, basically. Then we have the sort of distinguished head of design, the person who makes it so that when you look at it, you sort of have basically the pleasure obviously comes to mind. And that leaves us to the head of data. So with that out of the door, I guess that's enough you need to know about with regards to the introductions. The sort of talk I was supposed to be sort of having was about analytics engineering. And that's a similar sort of a story in here, similar kind of animal. Because when you look like who is an analytics engineer, you find blog posts like this. An analytics engineer is really just a piece of data analyst, ladies and gentlemen. And so it doesn't stop there. It doesn't stop there because when you sort of like look forward, then it says, all right, oftentimes an analytics engineer is really just a piece of analyst. We heard that, but now comes the kicker, who has the tools and motivation to make things better for everyone else. How nice is that? So what we'll spend the next 10 minutes on will be basically discussion on this, like what sort of tools and what sort of tools are there for people who would sort of call themselves analytics engineers? I mean, Cookie would on a good day, but what would they normally use to make things better for everyone else? All right, ready? I promised 3 parts. I guess we'll do it in 3 parts: the good, the bad, the ugly. You can spot the ugly by the color. It's the same color as my t-shirt in here. So the good. The good will be the things that works for us fairly neatly for us at Slido. And I guess it won't be much of a surprise if we say that the whole sort of dbt world was really a sort of big boon for us when we started using it. I guess it's like what, 16 months ago, something like that, perhaps even 18, perhaps even going down to 20. So the dbt offering has been very, very good to us. And like, let me sort of point out just three reasons why Honza and also Peter and Cookie as well, so Michael as well, talked about many things there, like things like the Jinja macros in here, or even things like packages and so on and so forth. Let me talk a bit about the basic stuff here. So the first thing that was a big thing for us was mostly the fact that like the dbt, it does tests and documentation basically in the very same code, or very close to the code that actually generates stuff, that actually generates the data, which ends up being your sort of product, if what you are is a piece of analyst, which is actually analytics engineer. So if you have tests and documentations close to data, to the SQL files that generate the data, it turns out they might end up being, you know, kept up to date even, or perhaps even useful, or stuff like that. And why is that? Mostly because when you're changing one thing, meaning in the data, in that SQL file, it's not all that far not in some sort of crazy wiki or somewhere where we store the docs, and let's not even go down to tests. So this is perhaps the first thing that got ported out from the world of software engineering. In there are these principles, these textbooks talking about things like you have to have the docs near the code and things like that for it to be useful and like get up to date and so on and so forth. Tests, same deal. All right, so test docs. The other thing is exposures. Okay, raise of hands. How many of you ever heard about exposures in DBT? Raise your hand. Very good, like 3 people, and 2 of them are from Productboard. Okay, so in that sort of a way, exposure is a simple concept. Effectively, if I have a DBT model, a materialized view, can I please sort of note where am I using it? Like outside of DBT, outside of my model. And now, all right, that's a rocket science idea, really. But in principle, even though this is very simple, like a very, very straightforward thing, it helps massively, especially if you connect it with stuff like, all right, this dashboard is powered by this sort of a model. What you can then do is when you sort of go down and try to change stuff, you can go, very cool, where am I exposing this piece of data? What are the sort of documentation files? What do we say? Perhaps what are the dashboards where I can see this? And by doing this, the Q&A, effectively making it so that, the QA, making it so that you can sort of rest assured that you don't break stuff, gets way, way easier. So the second thing, very good, worked for us, exposures. And the third thing is something that will be massively, but most probably very, very massively, not that obvious as a positive, are these analysis. So I won't even ask, but analysis are basically the same thing as models in DBT, with the small, there's just a subtle difference in the sense that they don't generate models, they don't generate materializations. And the obvious question is like, what is that then like useful for? Well, it turns out, even if you do analysis, that's just one-off, but your CEO is gonna do a 200 million decision on it, it might make sense to get it peer-reviewed. And so in that sort of a way, having an analysis, having something that sort of sees the eyes of other people is a very helpful thing. So you can still use all that you know from DBT there, all the Jinja macros, all the packages, and all the stuff the guys already talked about. Yet it's still normally part of some sort of a repository of your data code. So the 3 things that work for us very neatly: the tests and docs, the exposures, and the analysis. Well, going forward, I guess we can talk a bit about the things that the things that were like sort of bad, the things that we had to build. And why was that? Mostly because, well, I guess it warrants a 30-second personal story. I'm not even a software engineer. I'm a computer scientist by training, in this crazy artificial intelligence kind, like this, the absolute worst kind there is. But like I somehow got in the position of being sort of responsible for data things. So I did the only thing people do when they are sort of in this sort of position. I started to port stuff that I knew that worked elsewhere. And one of the things that worked very neatly in other engineering dimensions, even in this crazy AI world, is this. If I have tests, if I have documentation, wouldn't it be nice to be able to compute the coverage on my project? In other words, if we know that we are generating sort of 10 columns, I would very much like to know how many of these columns are effectively covered by the documentation we have and by the tests we can sort of run on them. Why is that cool? Because if you have tested code, if you have sort of tested, I mean, it's on the order of unit tests, but still, if you have something that tests your materialization, tests your transformations, your sleep will get way better. And so we built it. It's called DBT coverage. Well, I did nothing here, but Cookie and some other people from Slido built it. And so DBT coverage is to be DBT what coverage py and interrogate, these are sort of Python packages, are to Python. These are basically these 2 things combined. It allows you to compute the coverage of your tests and coverage of your docs on the DBT projects you are working on. It's as simple as you would expect it to. You go dbt run, you go dbt docs generate, and then you go dbt coverage compute with the coverage report going somewhere. Very cool, and you get this sort of coverage report, which at the end of the day says, yeah, on 15 things out of 38, I found something, your coverage goes to 39%. And you can obviously see having something like this in your CI/CD pipeline or something, or having some sort of do not sort of break my coverage level, something on that order, that it allows you to make it so that the new stuff changes, that new stuff gets added, your coverage doesn't decrease. The obvious best case scenario would be 100%, but we all live in the real world. So the thing there is then you can easily sort of also do the coverage differences between two runs. So like assume you have something in your sort of main or master branch, and you know the coverage of that. You can do that. You can sort of compute coverage on your specific branch, compare the two, and see things like, okay, you missed this new column. What are you gonna do about it? And then, like your PR reviewers, like Cookie, will basically come and smile. So this is open source, and many things will be in here. But it turns out it wasn't there. It didn't exist. So we did the only thing we knew how to do with things like this. We built it, and it worked fairly well, but it was still bad as we had to build it. Very cool. Next thing, similar idea. So we use Superset, which I am not gonna do the raise your hand thing, but we use Superset, which is basically an open source business intelligence platform like Tableau, but for the poor of, well, for the poor man, which we used to be and basically still are, at least at heart. Superset effectively allows you to make use of basically any data source there is. But what we were struggling with was like, how do we keep track which models are used in which dashboards that we have? And like these are, like, as you can imagine, hundreds and thousands of dashboards. So basically Cookie couldn't take it anymore, got up and built what was, and again with some other people, but still he was leading the charge there, built what we call dbt superset lineage. And what it does, it uses that concept of exposures. Look, you basically come in, you do, you sort of compile your project, you set up your access to Superset, as would be doable in Looker, in Power BI, in anything basically. Then you run this dbt superset lineage thing with some sort of an option saying pull dashboards from some sort of a URL. You run the docs, you serve them, and what you get in the end is something like this. So I have this customers table. It's referenced by some sort of tests, but along other things, it's also referenced by these sort of exposures, which is like this dashboard in here. So take a look at that. Like, Lugma, no hands. We basically run one command, but we can easily see where the things are going, and it helps us massively to sort of keep track of data. That's the question Cookie didn't take, which is like, how do you govern all this? We automate whatever we can, because otherwise we are done, basically. And we hopefully wouldn't want to get there. So second thing, superset lineage. And the final thing I wanted to sort of leave you with is SQL fluff. SQL fluff is something that I was missing from the first day, basically. How do I make it so? How do we make it so that I don't screw up when I go and sort of change some code that we have in these repositories? Or even better, how do we make it so there's no discussion about things like where do we put the commas? Or like where do we put the, like, do we do tabs or spaces? Or do we do tabs by 2 characters or 4 characters, and these sort of things. So long story short, SQL fluff, we were close in using it very, very early on. We still are. And it's something that you can use with whatever SQL you're writing even right now. dbt is supported out of the box with the references and whatnot. And it basically sort of for SQL that doesn't conform to what you would like it to conform to, it basically tells you things that the linter for JavaScript, Python, or whatnot would tell you something like, yeah, on line 3, you have this sort of an error and whatnot, things like that. Crazy stuff. SQL fluff for some of these rules can even fix it for you. So what you normally do is you run SQL fluff fix on something, hope you don't break stuff, get it sort of peer reviewed, and then also hope for the best, but most probably take a vacation. Anyhow, if there is a thing I think you can start using right now, even if you don't use dbt, it's probably SQL fluff, so go check it out. the third thing that was in the bed. And so that kind of, and we have bonus slides. So the bonus slide in here is that you can then sort of, if you have SQL Fluff set up, you can sort of hook it up to your CI/CD pipeline and have things like this reported. So look, you changed the exposure latest to uppercase, but we have a kind of a rule on that's called L014, which says unquoted identifier must be consistently lowercase, like this sort of deal. So like, you know what the, you know, like something you really don't want to sort of read from your colleague. I mean, that sort of changes the workplace dynamics. And that's enough about that. But like in principle, it's way better if you have this automated as well, other than someone else picking that up and then having a long session about it. So you can even sort of then pull it to other things. This is called, I believe, DBT artifacts or something like that. Again, if you're interested, I'm happy to talk about that and talk about all the questions we get, even Cookie got later on. So the other thing, SQL Fluff. And that leaves us with the ugly. So it's not all roses, and there are things we would still like to sort of improve and most probably build, because this sort of environment is changing by the day or by the night at Slido. And the ugly sort of like would sum it up fairly neatly in three things that we are totally missing, which is that if at all possible, we would very much like to go to actual integration or end-to-end tests. So what we were talking about on DBT level, that's like unit testing code. Like you are testing very small part of what's happening in those DBT pipelines. Whereas what we would also like to do is to do it end-to-end. Like, are we really sure that at the end of the day we'll make it so that stuff doesn't really change, doesn't really break? So again, I don't have like too much on it, but like I believe there is a lot to be done on that front. There's probably 2-3 startups, not in this environment, but like 2-3 startups to be built there as well. What we also desperately need is deeper Terraform integration. So even for things like Looker, I believe there are some Terraform adapters. What I mean by Terraform integration is that if we want to, worst case scenario, we can say, okay, let's pull all the dashboards we have in some sort of dashboards as code format, something like that. Let's kill the instance of Superset or Power BI or whatever that is that we have, and let's sort of build it anew somewhere else, because disaster recovery plan or something. Currently, this is very difficult to do. What we normally do would be getting that from backup. I would very much like us to go to a sort of plain text format where sort of copying a dashboard would be way easier. And again, I think we're getting there, but there's a lot of stuff to be done in there. Probably not probably on the open source front more than on the commercial one. And the final thing, which I believe is a deal breaker, but I'll still leak it in here, is that what we are, and we are building it basically at Slido, is that we believe there is sort of potential for having something like DBT to REST. Effectively, you give me a DBT project, I'll give you a REST API that will effectively expose the DBT project you have. The tests are there, documentation is there. The data types are already there. So all we need is a bit of a layer on top of DBT project, and we can probably directly give you an API. Why? That's cool. Your analytics engineers effectively are delivering something that really can be production, not just internally, but also externally. And that's currently ugly, but I believe we can make it better. We generally believe it's Slido. Let's put it that way. All right, cool. So the good, the bad, the ugly of analytics engineering. This sort of shows that the tooling is there. The guy who wrote the blog post was right. The tooling is there. But he also said something else, and this is also important. He says the momentum around DBT is palpable. That's one heck of a sort of intro statement. The rise of the analytics engineer is a real movement born out of necessity and genius branding. So I mean, like, do we agree? It again depends who is asking. If it's the HR department setting the levels and whatnot, I guess probably not. But in principle, this sort of hints at something, like this analytics engineer, in quotes, like literally in quotes in there. Like, are these people even engineers? Aren't we misusing the term? It turns out, like, this is a big deal even for software engineers. Like, there are people like this guy, Hillel Vela. He's a big deal in the formal methods community. And he literally, during Corona, did this sort of experiment. Like, he was asking, like, are we really engineers compared to like civic engineers or chemical engineers and things like that? Like, are we actually engineers, or are we sort of like making stuff up as we go and getting paid way more than the others? Well, he went very, very, very scientific about it, as well as very data-driven, as you can see. So his sample was like 15 people. By the looks of it, and there were chemical and civil and electrical engineers. I mean, we don't have to go through it. One guy, though, said a very important thing there, and is his friend, who's gone down low. You probably know him from different life. I think he's very cool, and he used to be electrical engineer, and now there's a lot of software engineering on big stuff, on big scaling problems in places like Twitter and Google. And so he said the practices aren't fundamentally any different than in software engineering. Well, there it goes. Some things were better, testing, formal methods, performance analysis, seeing the things we talked about, and some things were worse, like in electrical engineering. Version control, I mean, go check out the version control of a PCB. I guarantee you that's a fun night. Automation, mostly tools. So it seems there is something there, like we have tools that might be of interest, that might be even better than what the other engineering practices actually do. So there might be even things that the others can learn from us. And that's basically what this guy concluded, is that there were two things that were mentioned consistently, which was that if there were two things that people would sort of love to get to the other engineering disciplines, it would be version control. We all know that in here. But the other one is, surprisingly, openness. And by openness, we mean the open documentation, meaning you don't have to kill somebody to get the documentation, to the thing you are working on, or get signed an NDA that you basically says that your firstborn child goes to some corporation or something. The fact that we have open source, that we can go and build stuff on top of other stuff that's already like out there, and the fact that we can have conferences, open conferences, what they say, which is that open conferences, by that they mean there is no one trying to sell you stuff. So like, you don't go to a conference where people sort of like try to sort of sell you a new thing. Their vendor, they're basically their employer sort of told them to sell you, because that's how the electrical engineering and all the other engineering faculties generally work. Like, there are no events like this one where we can openly talk about various technologies, various things that are open source, various things that are interesting, and various things that are basically on the cutting edge. And so on behalf of all of Slido, especially the 5 of us who are in here, I would very much like to thank the Productboard guys for inviting us, for organizing this whole thing, and making it so that we can be a group, effectively, who seems to be sort of engineering in some sense, but that can have events that are open, and open in the sense that that we can have discussions that are basically not happening anywhere else. And I sincerely hope that at some point we will be able to repay their sort of kindness in kind as well. That's me, ladies and gentlemen. Thank you very much. So do I do the Q&A? Yes. All right. When do you time to work with business stakeholders if you do this? We normally don't. Very good. What's up with this? Who programmed this? Probably me. Come on. All right, well, sorry, send it again. How many DBT tests do you have? What do you test in your models usually? Tests on the order of hundreds. What do we test? Normally the absolute bare minimum stuff. So things like, can this have nulls? Can this be empty? is this some sort of a string that has some structure? Normally we start there because that catch is like 80%, like the Pareto principle is in there. I would sort of suggest if you are starting out, start simple, but do start, because otherwise you are basically fighting a lost fight. How come you know about DBT so much and are not a member of local Slack in DBT Slack? Because Cookie is there. What did you do? What did you do before Slido? Where did you build your knowledge? I was at DuckDuckGo, this sort of search engine you might have heard about, which doesn't track you. And where did you build your knowledge? Let's just say sleeping is not my sort of strong suit. Where is the line between analytics engineer and data engineer? You tell me. So thank you very much, ladies and gentlemen. It was fun to be here.